Hi, this photograph is one of the most reproduced and most famous photos of all time. It was taken by the Apollo astronauts as part of the missions to the moon in the late 1960s. This photograph is often called the blue marble, from a description that one of the astronauts made of seeing Earth uh, as uh, this single entity, this ball, for the first time it had ever been seen in this way, as the Apollo spacecraft headed towards the moon. It's an interesting way of looking at the planet, and one that is thought to have really triggered the environmental movement on Earth, as it became very apparent of the finite nature of the planet, spaceship Earth, if you like. Now, for us geologists, when we think about Earth and what makes it really special, we need to consider a concept that we call the Goldilocks Planet. What is it that makes Earth so special? It's certainly unique in our solar system. It's likely to be unique within our galaxy, and it may even be unique within the universe. Although that's something that probability would suggest is unlikely. But we certainly know that this planet is extremely unusual. We need to think about why this is. We need to think about this concept of the Goldilocks planet. I'm sure I don't need to remind you the story about Goldilocks eating the bear's porridge. I want you to watch the video, and at the bottom of page 2 of your booklet, I want you to uh, write about your opinion. To what extent do you agree with the idea of Earth being the Goldilocks planet? So, if we press pause now and watch that Goldilocks planet video, see what you think. Okay then. Now you've watched that video, think about the position of the Earth within the solar system. We are at the right distance from the sun. Closer to us, the temperatures we've seen are too hot. Further away, the temperatures are too cold. We're in this zone where we can have water existing in three different states of matter: solid, liquid, and a gas. It's crucial for the development of life. But clearly, that temperature on its own isn't enough. There will be other planets in different galaxies and different solar systems that are also within that same zone, yet won't have the conditions to form life. Now, to assess uh, the other things that may have an influence, our atmosphere, gravity, for example, we need to think about why Earth is so special. What makes the rare Earth? Now, there are 5 different aspects to this. There's our volcanic activity because of our active crust, the atmosphere that we breathe, the gravity that the Earth has as a result, largely of its core. With the core as well, we have the Earth's magnetic field that has a heavy influence. And it relates back to a theory that we have about the early Earth, related to an idea we call Theia. Now, what we're going to do is going to watch a program made by Professor Ian Stewart called Rare Earth. We're going to watch about half an hour of this program. With that then, as you're watching, I want you to be making a mind map. Using this diagram as the start for your mind map, what is it about each of these factors that influence our Earth being capable of supporting life, of making it a rare Earth? Write down your ideas as you're watching. Once you've watched that, I'd like you to answer the questions underneath. For each of these 3 planets, Earth, Mars, and Jupiter, I've picked the largest moon. And I've worked out using the equation of a sphere that's shown here what their volumes are. This is the data that you need to answer the question about the percentage volumes. Once you've watched the video, have a go at calculating the percentage of each of these planets that these largest moons would take up. Perhaps it might show us just how unusual Earth and its moon actually is. Press pause on the video to be able to note down these numbers.